We are now going to conclude our triangles proof section by doing Cpctc, which stands for corresponding parts of congruent triangles are congruent. What is Cpctc? It stands for corresponding parts of congruent triangles are congruent. You use this when you are trying to prove that parts are congruent. But first you must prove that the triangles are congruent. So we're going to do these steps the same way we had done before. Right? For the example 1, it says, given that segment AB is congruent to segment AD and segment BC is congruent to segment CD, prove that angle BCA is congruent to angle DCA. So the first thing, again, we need to mark our picture so we can figure out what we're going to go with. So I already marked that AB is congruent to AD. And now I'm going to mark BC is congruent to CD. And now looking at the picture, I have AC is the common side for both of these triangles. So that means that AC is congruent to AC. Now looking at the picture, I can clearly see that we have all three sides matching with a corresponding side. So the triangles are congruent by side, side, side. Again, I'm going to circle that so I know which way I am going. And then since I know that these triangles are congruent, I can say that these two angles that I need to prove are congruent. Now again, this actual proof at the bottom is open, so you can do it in different ways. Again, my step is to start off with what I'm given and work my way through the problem in that order. So again, given segment AB is congruent to segment AD, that satisfies the first part of my side, side, side theorem, and again, I was given that, so that is my reason. Now, since I already have one of my S's satisfied, I'm going to move to my next given, which is segment BC is congruent to segment CD. Reason for that, again, given. My third side is segment AC is congruent to segment AC. Reason I know that is because it's the same line, so it is reflexive property. So now I have all three sides needed to prove the triangle is congruent, so I can say that triangle ABC is congruent to triangle ADC by side, side, side. And now that I have the triangles congruent, I can now say that the angles BCA is congruent to angle DCA by Cpctc. Our corresponding parts of congruent triangles are congruent. Alright, so now let's look at example 3. Example 3 says x is the midpoint of segment WY and segment VZ. We're trying to prove that angle XWV is congruent to angle XYZ. So, starting off with this, we're going to mark about the information given. Since x is a midpoint of WY, we know that WX is the same as XY. Also, x is a midpoint of VZ. We know that VX is the same as XVZ. We also can get that the angles on the inside have to be the same because they are vertical angles. Therefore, now we have an angle in between two congruent sides, so these triangles will be congruent by side angle side. So there's the actual steps that I'm going to work through to get to this. Since I know these triangles are congruent, I can then say that the angles that we're trying to prove congruent are congruent by Cpctc. Now, to start off with this, I need to start off with what I'm given. X is a midpoint of XY and VZ, reason given. The first thing that we got from there was now that segment WX is congruent to segment YX by definition of midpoint. The second step from that same one we got was that VX is congruent to ZX by definition of midpoint. Now I have two sides that we know are congruent. We need to do the angle. So we're going to say angle WXV is congruent to YXV because they are vertical angles. Now I have all three parts of my triangle congruence theorem. So I'm going to say that my triangles WXV is congruent to triangle YXZ by side angle side. Now that I have the triangles proven congruent, I can say that the angles WXV and XYZ are congruent by Cpctc. Now, looking at example 5, we're given that segment BC is parallel to segment EF. D is the midpoint of segment BF, and we're trying to prove that segment ED is congruent to segment DC. So again, we're going to start off by marking our picture. We know that BC is parallel to EF, so we're going to mark that with arrows. We know that D is the midpoint of BF, so BD must be equal to DF. Now, we actually end up using that the lines are parallel to show us a couple angles are congruent. Angle B is congruent to angle F because they are alternate interior angles. Also, angle C is congruent to angle E because they are alternate interior angles. Now, with this one, you could have also ended up using the vertical angles on the inside and used a different theorem for this. However, this is the way that I decided to use this problem. So now we have the angle next to the angle next to the side, so the triangle is congruent by angle, angle, side. Circle that so I know which way I'm actually going to do the problem. And then, since I know that it's congruent, I can now say that segment ED is congruent to segment DC by Cpctc. So again, I'm going to start off with what I'm given. Alright, sorry, I had to make the correction. BC is parallel to EF was given to us. Then, that tells me that angle B is congruent to angle F because they're alternate interior angles. And angle C is congruent to angle E because they are alternate interior angles. Then it gives us that D is the midpoint of BF because it was given. That then informs us that segment BD is congruent to segment FD by definition of midpoint. Now we have both angles and the side for the theorem. We can say that triangle BCD is congruent to triangle FED by angle, angle, side. Now that we have the triangles congruent, we can then say that segment ED is congruent to segment DC by Cpctc.